I'm just kidding. So hope you guys are off to a good Thanksgiving break so far. Some of you are getting started way before Thanksgiving break happens, and that is totally what I would not have done, but go you, right? I'm a last minute procrastinator, so I would have been up at like midnight on Sunday night trying to get it done before we came back to school on Monday. But hey, so I am doing an ed puzzle for you guys that will count as your Monday and Tuesday assignment for the week. For those of you that are in class, you got a copy of the notes for this section. For those of you who are quarantined or, just skipped school. All right. You guys can access your notes in Schoology. There will be a copy of that there. Or you can take handwritten notes if you want, but hey, it's on you. So we will be talking about elements, mixtures, and compounds. So we're moving back into elements, mixtures, and compounds because in the next couple of weeks, we will begin transitioning from elements, which are our pure substances, into compounds, which also do remain pure, which we'll talk about a little bit. But we'll be moving into bonding, how they bond, why does the periodic table help us understand who can bond with who and that type of thing. So we'll be looking at ionic bonds, covalent bonds, and then we'll dive into a small touch of balancing equations. All right, it's not difficult unless you panic and you tell yourself, I don't get it, because then you'll never get it. But just stay calm. All right, I'll try to answer any questions that you have along the way. I may not always do the best job, but I definitely try. So as we go through this, you guys are going to watch, you're going to take notes, and then I will ask a question through Ed Puzzle, and you guys are just going to type in, and we'll give you a grade that way. Also, if you take good notes, then you should make a good grade. If you take bad notes, then now's the time to start taking good notes. So with elements, mixtures, and compounds, it begins by asking the essential question, how is matter classified based on its composition? So we'll be looking at 3 different classifications that it may fall under based on how it's composed. What's it composed of? Are they chemically bonded? Are they not chemically bonded? And so forth. So the first question that we have to ask ourselves is, what is matter? Not what's the matter, because what's the matter is like coronavirus, school, I hate my friends, and I don't know. So not what is the matter, but what is matter. Remember, matter is anything that has mass and takes up space. So in your notes, you have a couple of examples that we'll look at. I'll let you guys try to determine if it's matter based on the facts of, does it have mass? Does it take up space? If it has mass and takes up space, if it's matter. If it doesn't have either of those or is lacking one of those, it is not. So what is a pure substance? Actually, let's go back and we'll look at these really quick. So on your paper, you have matter is anything that has mass and takes up space. Then we have the substances of air, light, energy, bacteria, magnetism, and stars. So we're going to go through them together and try to answer these questions. Is this matter? All right, so air. What do you guys think with air? Does air have mass and take up space? Well, yeah, we hope so, right? If it didn't have mass or take up space, then you guys wouldn't be able to breathe it right now. But it is all around us, so it does take up space. Even though its mass may be incredibly small compared to other things, it does have mass and take up space, therefore it matters. What about light? Now that's a tricky question. Now we're not talking about a light bulb. We're talking about just light. And the answer is no. All right, doesn't have mass, doesn't take up space, we can't measure it. What about energy? Same thing there. Energy is not counted along things that have matter or have mass and take up space because we cannot measure the mass and it doesn't really take up space. What about bacteria? Yes. All right. Bacteria, even though its mass is incredibly small, it does take up space and it can wreak havoc. For those of you who have ever had any type of bacterial infection, you know that it absolutely stinks. Bacterial infections are any infections that you can treat with antibiotics. Okay, so we're not talking about like the stomach virus. A virus you cannot treat with antibiotics. But we're talking about things that are actually caused by bacteria, such as a sinus infection, that type of thing. And then magnetism. Magnetism is another example of something that does not take up space or have mass that we can measure. And then lastly, the stars. While we necessarily can't figure out their mass, someone can, much larger than our pay grade, right? And so stars do have mass, and they do also take up space. So along the lines, air, yes. Light, no. Energy, no. Bacteria, yes. Magnetism, no. And then lastly, stars, yes. So that carries us on to the next question. What is a pure substance? When we're looking at pure substances, we're looking at substances that are made of the same material throughout, and they have the same properties throughout. So it doesn't have different properties based on what it's composed of. It is the same throughout, the exact same thing throughout. A good way to decide if it's pure or not is like pretending you're holding it in your hand. Ask if what you have in your hand is just one kind of substance, meaning like, is it all made up of the same thing? So I could have gold, and I would be able to say yes. I could have a ring and say, no, it's not necessarily all gold. It's an alloy, so I know it's probably gold and nickel or gold and something, so therefore it wouldn't be pure all the way through. When it comes to properties of pure substances, you guys know that we've been looking at this for the last couple of weeks when we've been looking at characteristic properties of pure substances. We've looked at density. We've looked at melting point, boiling point. You also, in that category, have malleability, whether or something is able to bend is a physical property. Why? Because we're not changing it into a new substance. We still have what we have. We're just changing the way it looks on the outside. With chemical properties, we're looking at, is this substance able to react? Does it have reactivity? We're looking at, is it flammable? Okay. Or does it have a certain level of acidity? Okay. Is it able to rust? That type of thing. So physical, we're just observing it. Chemical is changing it into a new substance. What is the simplest form of pure matter? So that's our topic question number 3. It's our first section in the elements, mixtures, and compound notes. So we're going to start off the bat with elements. You guys should be familiar with them as we've covered them in some detail looking at the periodic table. But elements are the purest form of matter. Elements cannot be broken down into simpler substances. So some of you are going, but when we learned about atoms of an element, we learned about the subatomic particles being the electrons, the neutrons, the protons. Yes, it has those particles, but individually those don't make up the entire property of an element. So element is literally like the tiniest bit that we can get down to and still have all of the same characteristic properties. So we can't break it down any smaller. Any amount of a pure element remains the unique physical and chemical properties of that element. So if we have one single atom of an element, we're still going to have all the physical properties as well as all the chemical properties of that substance contained within that element. Remember, when it comes to elements, there are 118 of them, give or take on the periodic table. Some are naturally occurring, some are man-made. Among those, we have metals, we have metalloids, we have nonmetals. Remember, they were in their groups based on the number of valence electrons, or the electrons that they had in their outer shell. So all of the ones in that family have the same amount of valence electrons. That will be very important when we start the bonding section. When it comes to elements, there are 118 of those, again, give or take in the periodic table. And again, if we're going to talk about the elements, if we're shorthand writing them out, we can write their chemical symbol. Remember, if we're looking at the box on the periodic table, it will say, like, it'll have a symbol, which is just 1 or 2 letter abbreviation for that element. Then it will have the element name underneath. Underneath that, it will have the atomic mass. And in the top number, it will have the atomic, or in the top right corner, it has the atomic number. So the symbol is our 1 or 2 letter abbreviation. Sometimes 3, the man-made ones will be like UUV or UUB. But most of them are 1 or 2 letters, and the first letter is always capitalized. So if you have a compound, which is what we're going to be looking at in the next slide, to figure out the different elements we have in the compound, you just look for a capital letter. But when it comes to elements like single, in their single form, we abbreviate them with the first letter being capitalized, the letters that follow being lowercase. So if we're looking at sulfur, sulfur is going to be abbreviated with an S. If we're looking at Magnesium. Magnesium is abbreviated Mg. If we're looking at iron, iron is abbreviated Fe. And I know, guys, some of you are like, wait, I don't remember why iron is abbreviated Fe. Remember, they are abbreviated based on their English name or their Latin name. So while sulfur and magnesium are abbreviated based on their English name, iron is abbreviated based on its Latin name. The Latin name for iron is ferrous, so we abbreviate iron Fe. For neon, we have Ne. For calcium, we have Ca. For helium, we have He. And then for carbon, we have C. Now remember, it's important if I ever ask you to give me the chemical symbol of an element, of a specific element, you want to make sure the first letter is capitalized, second letter is lowercase. If you do not do that, it will not be correct. So those two things are very important. Topic question number 4. What is a diatomic element? All right, di means 2. Okay, so anytime you see the prefix di, you know it means 2. Atomic just means atoms. So if we have a diatomic element, we have an element that's made up of 2 atoms. All right, a diatomic element is an element in which in its pure form is always bonded to itself. All right, kind of like twins that are always together. Some of you are twins. You're like, never together, hate being seen together, Parker and Harper. Maybe I'm talking about you, maybe I'm not, I don't know. But when it comes to diatomic elements, in nature, these 2 atoms are always found bonded together. They're never going to be found just floating around by themselves. Oxygen is one of them. You will never find oxygen in nature as just O. All right, you'll always find it as O2. The 7 of them that do exist, there's a mnemonic for it. It's kind of funny. Kind of not. I have no bright or clever friends. Some of you are like, it's true. If you're sitting there and you're like, no, man, all my friends are pretty smart and they're definitely clever, then you might be the one in the friend group that fits this sentence. I'm just saying. So the way that you can remember it, the first letter of each one is represented by an element. I is iodine. Iodine will always be found as I2. All right, this 2 right here is the subscript. It's found below the I, so I2. All right, have is H2. No means, no stands for nitrogen, or the N in no stands for nitrogen, so that will be N2. Bromine, Br2. So capital B, lowercase r2. Oxygen, O2. The C in clever stands for chlorine. That's capital C, lowercase l2. And then friends is for fluorine, and that's FL2, I believe. No, just kidding. Just capital F with a lowercase, with a subscript 2 underneath it. So 7 diatomic elements that exist in nature, all right, meaning they're never going to be found unbonded. They're always going to be found bonded to another atom of itself, are iodine, hydrogen, nitrogen, bromine, oxygen, chlorine, and fluorine. And remember that I have no bright or clever friends. What is matter that is composed of more than one element? So this is our topic question number 5. What is matter that is composed of more than one element? So matter that's composed of more than one element is called a compound. All right, compounds are pure substances that are made of 2 or more elements that are chemically bonded together. All right, that is an important statement. In order to be a compound, they have to be chemically bonded, meaning if we ever want to separate them, we have to do that by chemical means. We can't just be like, go, gadget, separate, whatever. We have to use some type of chemical reaction to separate the 2. So examples of compounds that you guys would be familiar with. H2O. All right, H2O is a compound of hydrogen and water. All right, they're always going to be found in specific ratios too. Carbon dioxide, CO2. Now remember, in order to tell how many different elements we have in a compound, we look for capital letters. Here we have carbon and oxygen, and we know that because we have a capital C and a capital O. So if I ask you how many elements do I have in this compound, the answer would be 2 because I have 2 different elements, carbon and oxygen. If we look at calcium carbonate, which is what seashells are made of, I can also count my elements here. Remember, look for that capital letter because it indicates that we have another element. So here we have C with a lowercase a, so calcium being one element. We have a capital C, which stands for carbon, so that's our second element. And then we have a capital O, which stands for oxygen, and that being our third element. It's very important to note that a compound is going to have different properties when it's bonded together than if we just had those same individual elements. So carbon dioxide has both carbon and oxygen, but its properties are going to be different than either carbon or oxygen. So when they do bond together, they take on totally different properties. So while carbon may boil at a certain boiling point and oxygen may boil at a certain boiling point or melt or whatever at a certain boiling point, or it may have a certain color about it or certain density about it, these guys are going to be completely different. So carbon could be blue. All right, I'm just giving you an example. It's not, but it could be blue. But when bonded with oxygen, it could be green. All right, so it doesn't necessarily have to have the same property because it is a new substance. All right, so again, with compounds, energy must be taken in or given off when a compound is broken apart or put together. So in order for compounds to form, energy is required or can also be given off. In the same sense, when they are broken apart, we have endothermic versus exothermic, and we'll look at those types of reactions as well. But when they're broken apart, they can also require energy to break the bonds. And if they require less energy to break the bonds than they give off, then it will be exothermic, and they'll be putting energy out of the system. But in order to create a compound or in order to break apart a compound, energy has to be taken in or given off. Separating the elements in a compound requires a chemical reaction. Again, there's no you can't just take water and separate oxygen and hydrogen from each other. You have to have some sort of chemical reaction occurring. Chemical formulas represent how many atoms of each element there are in a compound. So what you're seeing here, H2O, that's the chemical formula for water. What you're seeing here, C6H12O6, that's the chemical formula for sugar. NaCl, chemical formula for salt. And then NaHCO3 is the chemical formula for baking soda. So they represent how many atoms of each element are a part of the compound. Right now, I'm not going to ask you to count each atom of each element, but it's very simple. All you do is look at the subscript. So we are able to tell how many elements we have based on the symbols that are included in the chemical formula. So again, first letter is always capitalized, second letter is always lowercase. So if I look here, I have Na, okay, which represents sodium, and then I have C, capital C, lowercase l, which represents chlorine. So I can count that I have 1, 2 different elements in this compound. Here I have capital C, capital H, and capital O. So I know I have 3 different elements in this compound. If I wanted to count how many atoms of each element I had, I could do that as well by looking at these numbers here, which are called our subscripts. So I have C6, which tells me that I have 6 atoms of carbon. I have H12, which tells me I have 12 atoms of hydrogen. I have O6, which tells me I have 6 atoms of oxygen. If you're going to look at H2O, I have 2 different elements included in that compound, hydrogen and oxygen. Here I have 2 atoms of hydrogen. To look at oxygen, I know that oxygen's written down, so I at least have 1 atom. So if you don't have a subscript, it's understood to be 1. And so since there's no subscript following oxygen, I know I have 1 atom, because if I didn't have any atoms, it just wouldn't be written. It would be like me asking you, how many atoms of carbon do I have in H2O? The answer is none, because there's no carbon atom in water. And then NaHCO3, I can count that I have 1, 2, 3, 4 different elements. I can also look and say that when it comes to atoms of Na, I only have 1 because there's no subscript. When it comes to atoms of hydrogen, which is represented with the H, I have 1 because there's no subscript. Carbon, I have 1, again, no subscript. And then oxygen, I have 3 atoms because we have the subscript 3. So just by looking at the chemical formula, you're able to tell a lot about the compound. Next, we have mixtures. So topic question number 6 is, what is matter that is composed of more than one substance. All right, a mixture is composed of more than one substance. Mixtures are not pure substances. So this is the first thing that is not a pure substance. Elements, they are pure substances. Compounds, they are pure substances. Mixtures, they are not. All right, their parts are not chemically combined. So they just exist together. So they're only physically combined. They are not chemically combined. So if you want to separate them, you can do so without a chemical reaction. It's kind of like a hamburger. Hamburger is an example of a type of mixture. Okay, if I order a hamburger and I say no pickles and they put pickles on it, I don't have to go through some kind of chemical reaction to take the pickles off. I just lift the bun up, take the pickles off, put it back down. Right? Thanks, Chick-fil-A. They always put pickles on the chicken sandwiches, and BJ hates them. So maybe you're on the hate pickles on your chicken sandwich gang. All right, you're not alone. All right, so their parts are not chemically combined. They only physically exist in the same spot. So when substances are combined into mixtures, they keep their own properties because a new substance has not been formed. All right, just because I have a hamburger doesn't mean that all of a sudden my tomato becomes lettuce. All right, they keep their own properties. When it comes to mixtures, there are two types of mixtures that you can have. The first one being homogeneous, second one being heterogeneous. We want to look at the prefixes, and that will help us understand those mixtures a little bit more. Homo means the same, all right? So anytime you hear the prefix homo, I know you're probably giggling at home, but that's how they get that. It means the same. So if we can try to be mature for 2 seconds, if someone is homosexual, they just like the same sex. That's all that means. So homogeneous mixtures, the parts are evenly mixed and they stay evenly mixed. So we cannot tell that we have different particles. We just know that we do. So with homogeneous, it looks the same throughout. These types of mixtures are also known as solutions. So air is an example of a homogeneous mixture. Even though air is made up of carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, when we see air, or when we don't see air, all right, we don't see the individual atoms. We just see, hey, they all exist together. Now remember, with air, carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur, they're not chemically bonded. They just all exist in the solution together. It's like looking at sweet tea. Price, shout out to you. We know that you drink 3 gallons a day. So when you look at sweet tea is made up of a couple of things: water, tea bags, and sugar. All right. So when we brew that tea, we know we have water and we know we have sugar and we know they exist together, and we know when they don't exist together because that is some nasty tea. All right. Maybe you guys have been to McDonald's, who used to be known for having the best sweet tea ever. But McDonald's, if you got unsweet tea when you ordered sweet tea, you definitely know something is missing from your mixture. But when you look at tea, if we sat 2 teas side by side, one had sugar, one did not, we couldn't tell the difference. Why? It's mixed evenly throughout. So that sugar is mixed evenly throughout. You've seen it when it's not. Maybe they put too much sugar in the tea and they weren't able to melt it or to get it to blend all the way. And you've seen the granules sit at the bottom. So we also know that that's an example of a mixture. There are also instruments that are made of brass. Some of you play in the band. Maybe you play a brass horn. I don't know. I was not in the band. All right. But not hating on it, because I do love instruments and I do hope that my kid plays some sort of instrument one day. Right. I play guitar, so I can't really hate on people that like music. Neither should anyone, because we all like to listen to music. But hey, but instruments are also, instruments are sometimes composed of brass. All right. Brass is a blend of 2 metals, those metals being copper and zinc. Now, even, they're not chemically bonded. They just exist together. So what's happening is they're creating this blend of a metal. It looks the same throughout, so you can't easily separate it. You would have to go through some intensive processes to get that to separate out, whether you are melting it down and one melts at a higher melting point, so you're able to remove that first substance out based on melting point. But we do know that it looks the same, so therefore we have a homogeneous mixture. Ketchup's a good example of that as well. Unless you leave it sitting on a table for too long, then you'll see that the vinegar begins to separate out of the top of that. When it comes to heterogeneous mixtures, they are not evenly mixed. Hetero means different, okay? Heterosexual, different sexes, that type of thing. So with heterogeneous mixtures, they're not mixed evenly. You can see the particles pretty easily. Again, think about, oh, ketchup was in this one. So think about a salad, all right? Some of you go to Olive Garden and you are like, I hate onions, okay? Whatevs. Or you hate black olives. And if you're that kind of person that hates black olives on your Olive Garden salad, hook me up because I love them, all right? But if you go and you get a salad and they have onions on it and you don't want onions on your salad, it's really easy. You just pick them out, okay? It's not evenly mixed. You can see the difference in the particles, so you just pick them out. Same with some soups. Maybe you don't like carrots, so you can just pick those out. Or, let's see, Chick-fil-A sandwich again. Or you go to the Mexican restaurant and they put veggies in your chicken and rice and it's the end of the world and you just have to separate all the veggies out of your chicken and rice, all right? When it comes to heterogeneous mixtures, you can have different types of heterogeneous mixtures. First one being a colloid. With colloids, you can see the different particles in a beam of light. So think about things like mist or fog. How many of you have ever gone outside on a foggy day, or maybe you're riding with your parents in a car on a foggy day, and the headlights hit the fog? You can see like the tiny little particles floating in the air. Super cool. You can also do that with milk. If you hold milk up to a light, you can see the different particles there. Suspension, particles settle to form layers over time. This is what I was talking about with ketchup. I think I might have called it homogeneous, but I mean heterogeneous. So again, if you leave ketchup sitting on the table, you can see over time that the tomato paste and the vinegar separate from each other. So you have like all of this nasty tomato paste and a layer of vinegar. Or you've been at a restaurant where you picked up like a ketchup bottle and you went to squirt it on your French fries and all of a sudden all this nasty liquidy stuff comes out. Yeah, super gross. But that's what's happened. The particles have settled and they formed layers. Why? They're not chemically bonded, so they can be separated. So what are some similarities and differences between elements, compounds, and mixtures? All right, just to hit up a couple of these. We'll start with elements. Elements, simplest type of matter. All right, building blocks of matter. You have to have elements in order to have anything, so these are our simplest types of matter. They're represented by symbols on the periodic table. So remember, those are 1 or 2 letter abbreviations, sometimes 3, but mainly 1 or 2 letter abbreviations. That first letter always being capitalized. Second letter, if there is one, will be lowercase. When it comes to elements, there are about 118 of those, some being man-made, some being naturally occurring. And they all have unique properties about them. Think like when we were looking at density, melting point, boiling point, that type of thing. Those are their physical properties that we've looked at so far. They also have specific chemical properties that we'll talk about a little later, especially when we look at them and bonding. Within the elements, we have this little subsection of diatomic elements. Diatomic elements are 2 identical atoms that are bonded together. These guys will never be found as a single atom in nature. They'll always be found bonded to another atom of itself. So remember, I have no bright or clever friends. Iodine, hydrogen, nitrogen, bromine, oxygen, chlorine, and fluorine. You will never find oxygen as O. You'll always find it as O2. You'll never find chlorine existing naturally as Cl. It will always be Cl2. At the top, we have compounds. Compounds are 2 or more elements that are chemically combined. So again, elements and compounds, pure substances, they're going to be chemically combined, all right? So compounds, chemically bonded. It took some type of chemical reaction to get them together. It will also take a chemical reaction to break them apart. Properties are different than individual atoms. Remember, oxygen and hydrogen come together to make water. But if we just have oxygen by itself, it will not have those same properties of water, same as hydrogen. Hydrogen will not have those same properties of water, but when you bond them together, they develop their own properties. And then with compounds, we have a chemical formula that will let us know how many elements we have, as well as how many atoms of each element we have composing that compound. What do they have in common with elements here? They're pure substances. So both elements and compounds are pure substances. Next, we have mixtures. Mixtures are two or more substances. They are not chemically combined. So these guys are not chemically combined. They're easily separated. There are two types of them, heterogeneous and homogeneous. And based on how they are put together, depends on whether or not they're homogeneous or heterogeneous. Homo look the same throughout. Heterogeneous look different. They also have something in common with the compounds. When it comes to compounds and mixtures, they both here are composed of two or more substances. Remember, element is just one substance, unless it's a diatomic element, then it's two of the same. But compounds and mixtures are both composed of two or more substances. And then what do all of these guys have in common? Elements, mixtures, and compounds. Well, there's only one thing, and that one thing is that they are all made up of atoms. So elements, mixtures, and compounds, all made up of atoms. And lastly, you guys have a sum it up page. This sum it up page is pretty difficult. All right. When we get back, we will be talking about it, so make sure that you're completing that. Take your time. You're going to use, if you look here, you have a graphic organizer. It's a web. All right. You're going to use the words on the left side to fill out that web. So if we're looking at substances, we know that substances include elements and compounds. All right. And then we'll fill out based on that all the way down. You have to pay attention to what's already been filled out so that you can see what you should be putting above and below that box that already exists. Number 2, it's sort the following substances into categories on the right. So we have elements, compounds, heterogeneous mixtures, and homogeneous mixtures. So you're going to put those in a category based on what you know about it. Obviously, elements are either going to be just single elements that exist on the periodic table or diatomic molecules such as O2, that type of thing. But remember, even with a diatomic molecule, it is one element and two atoms. Okay, so I2, O2, Cl2, Br2, that type of thing. Compounds, those are elements that have been chemically bonded. They are pure substances. You can look at a chemical formula for them. And then mixtures, they are not chemically bonded. And depending on if it's the same throughout or different, all right, you will have homogeneous or heterogeneous. If you have any questions, you can shoot me a quick email. Hopefully I'll respond. I'm not the best. I know that. You guys know that. But I will try to check those often throughout. And again, this is your assignment for Monday and Tuesday. If you complete it early, great. Hey, you're done. If you complete it late, hey, as long as it's by Monday that we come back to school, you're good. So if you are the one that's completing it today on Friday before Monday and Tuesday ever happen, kudos to you. If you're the one that's up on Sunday night at midnight trying to get it done really quick, I understand. I'm totally that type of person too. So good luck. May the odds be in your favor. If you need anything, shout. Hope you guys have a great Thanksgiving, and I can't wait to see you back on Monday. Bye.